Looks like we're live. Hello everyone and welcome to yet another recreational programming session. Let's make a little bit of an announcement and officially start the stream as usual. As usual. Red Circle, live on Twitch. And what are we doing today on Twitch at .television website? Today we are learning Fortran. And I'm gonna give the link to twitch.tv/study, and I'm gonna ping everyone who's interested in being pinged, and there we go, the stream has officially started. How about that? So what we're gonna do today we're gonna learn Fortran, and the reason why we're learning Fortran today is because it is kind of related to the deep learning framework that we've been developing for quite some time, for 2 months already. So as I can see in the GitHub, right? So 2 months. So essentially what I want to do, I want to be able to use the libraries, such libraries as BLAS, right? So have you guys heard about BLAS? It doesn't. Okay, BLAS and LPAC. So the original sort of like reference implementations of these libraries are in Fortran. Unfortunately, like this website actually blocks my IP, right? So I won't be able to go there, but maybe I'll just like pre-download this library for the next stream and stuff like that. So, and to be able to effectively use this kind of libraries, I think it is kind of important to at least be familiar with Fortran programming language, right? So, and that's basically the goal for today, just learn a little bit of a Fortran. So I don't remember if I ever programmed in Fortran, so yeah. So here's the thing, people keep asking me, how many languages do you know, right? So I tried so many fucking languages that I don't remember if I ever tried Fortran or not. Like, that's how many of them I tried. Like, I don't remember, seriously. Like, I tried too many of them. It's just like, because the languages are the same, right? So they basically rehash and the same ideas and reuse the same ideas, so I don't really see much difference between them. So I don't remember. I think I did something maybe for Advent of Code. I think I did something for Advent of Code, but apart from that, I don't remember doing anything super serious in that language, right? So, and I certainly do not remember anything from that language, that's for sure. So yeah, let's go ahead and try to maybe write hello world, right? Write hello world. So let's go. So the usual thing that you do when you learn any language, you write a hello world, or hello seaman, as we like to do that. Fortran. So I'm going to create a Fortran. And what's the extension of Fortran? I think let's actually go to Wikipedia. Fortran W. So usually they give you the, oh, it's F. Oh, I can remember that. There's also 4, F90. Is there F69? That would be actually nice if it was F69. So okay, main.f. So it already automatically recognizes that it's a Fortran. Okay, that's cool. You know what I'm gonna do? I'm gonna just like save this entire thing and I'm gonna try to compile. If I remember correctly, so the one of the like open source compiler for Fortran is GNU Fortran or G-Fortran. So, and this is probably what we're gonna use today, right? I know that there are several implementations of this compiler, but I'm gonna use the one that's available on my machine. So let's go ahead and just try to compile this entire thing. Main.f, and see what it is going to tell us if we just feed it an empty file. All right, so undefined reference main, that's actually very cool. So it already, yeah, that's funny. An empty program in Fortran compiled but didn't link. It compiled but didn't link. This is actually kind of interesting. So if I try to do the same thing with C, is it going to be the same situation? Why did it save it? Sometimes I just press something that makes it save the compilation buffer. I don't really know why. So if I like literally create an empty C file and just do gcc main.c, it's kind of the same situation. Never thought about that, actually. Never thought about it. Because people rarely try to compile an empty files, right? So usually it doesn't make sense. So I suppose we need to create a procedure, right? We need to create a procedure. But I don't really know how to do that. Okay, so this is a very old Fortran, I suppose. Simple Fortran 2 program. And I'm pretty sure this kind of thing is not going to work anymore. I actually wonder if I just like literally copy. Emacs actually still compiles, highlights this entire thing. But this looks like very freaking old, right? So it reminds me like these basic style references or labels where you just like write number as a label, so then later you can go to one of these labels, but I don't think they're actually going to any of the labels. But yeah, it's actually quite surprised that Emacs recognizes all of that, and I wonder if Fortran will be able to do that as well. Let's actually try to compile this in. Yeah, it cannot compile very old Fortran, right? It cannot compile very old Fortran, though Emacs does recognize this kind of thing. All right. So let's go and recreate this thing one more time and see how do you create a procedure. So this kind of stuff. Oh, that's literally hello world. You have to create a program hello. It's almost like a Pascal. It's almost like a Pascal. So let's go ahead and revert this entire thing. Right. So I have to say program. Hello, let's actually call it main, and then you have to say end program, and Emacs does not automatically indent it, but what if I put main? It doesn't automatically indent it. Right? So I have to do that, which is, wait a second, okay, 1 2 3 4 5. Okay, the letter E has a special meaning if it has 5 spaces in front of it. I don't know if it has anything to do with like an actual Fortran, or this is just like a bug of the syntax, but this is kind of fun. Right. I wonder if I can just like try to compile this entire thing. Is it going to work? So, okay. Non-numeric character in a statement label 1. Ha. So there is some sort of like an implicit label 1 in here, and you have a non-numeric character, which is, I suppose, new line. What if I put new line in here? Right, what if I put new line in here? And is it still go? Yeah, it seems to be. What if I put number in? Did you notice that? Wait a second. I put my cursor in here, and I just press 1. And this is what it does. So so essentially it still supports this like a very old style number labels, right? And Emacs also recognizes that, and it just like auto indents everything. And how many spaces do we have in here? 1 2 3 4 5. Well, it's not really 5, but I mean, yeah, that's a little bit weird. Okay, so what if I just leave this thing in here and try to compile this entire thing? It still says it like that. All right, so I'm just trying different things, right? So I'm just trying to see if the compiler can like literally tell me how to use this thing. So to write hello world, we have to do print star. I have no idea why it has to be star, but you have to put star in here, and then hello world. Okay, so is indentation important, I wonder? So then a comma, hello world. Is it going to work? No, it didn't really work. 1 2 3 4 5. Maybe even something like this. Do you have to put semicolons in there? I'm not actually sure. Unclassified statement. We're already off to a great start. Wait a second. What if I just copy-paste this entire thing like so? And then try to... It doesn't work, actually. It literally doesn't work. Welp. Okay, so let's try to Google out Fortran. So I know that there is a website, Fortran Lang, right, that has tutorials and stuff like that. So let's actually go there, because I want to try to understand what exactly am I doing wrong. Like, what precisely am I doing wrong? So there's some tutorials in here, a quick tutorial. Okay, so like we need to get past hello world. We need to get past at least hello world. Okay, so here it is. That's how it's supposed to be. Program, hello, and then we just have to do that. And classified statement at once, so it simply doesn't work. F90. Oh, this one is actually very interesting. Maybe I kind of remember this thing that the compiler behaves differently depending on the extension you use. Right, because there are several standards of Fortran that are kind of backward incompatible. Right, they're kind of backward incompatible, and because of that, the actual standard is determined by the extension, so you can sort of link several Fortran source codes written in different standards or something like that. I kind of vaguely remember that. Right, so let's actually do the following thing. Let's rename the extension to 90, right, and try to compile it with this. I was right, holy shit! What a language! Holy fuck! So that means F is sort of like an older or something, I think. That is so weird. Like, yeah, but if you rename it back to that, you won't be able to compile this entire thing. Wait a second, right? So you're just not able to do that at all. But what if you put like a label in here? Maybe that's what it wants. Maybe it wants a label. No, it doesn't want a label, right? So I suppose we're going to be using the standard from 90s, right? So we're going to be using the standard from 90s. All right, so nice to know. That's pretty cool. That's very funny. All right. And it says hello world, but for some... Why did you put the space in here? What? I didn't put a space in there. Why the fuck would you put a space in there? Wait, what? Is that because of this? By the way, what is this star even? What is the star? Why is it not just print hello world? Why does it have to be star? Like, just because? Just like, there's no reason to have this star. Like, what is it? Missing leading left parenthesis in format string at. No, you're missing star. Why when I remove the star, you're telling me about missing parentheses? What kind of error messages is that? But if I put star in here, it compiles everything correctly. But then when I run this thing, it has an extra space in front of it. So far, this language feels like just arbitrary bullshit. Like, nothing makes sense. Like, why? Why? Try parentheses. Okay, so you mean I should try something like this? No. So parentheses don't work. So chat doesn't know what they're talking about as usual. All right. So I wonder if this is because of this space. Right. So let me see. Okay. So it always puts this space in front of this thing, and I suppose it's not a bug. Right. It's not a bug. It's a feature. So you just have to suck it up. I suppose you just have to suck it up. All right, so yeah, we're gonna be using this thing to learn. I wonder if we can just like, so here is the, yeah, so this is what we're using. This is what we're using. Now, let me see. So this is the references, and this is from where we're learning everything. All right. So this is just hello world. And by the way, look at that. It doesn't have a space in front of it. This is a lie. Like, why are you lying? Why are you always lying? My God. Okay, so how do you define goddamn variables? So, yeah, variables are stored information that can be manipulated by the program, blah, blah, blah. There are 5 built-in data types in Fortran. Integer, real, complex, character for text data, and logical for data that represents Boolean, true or false. So Fortran doesn't have Boolean. It is called logical. Declaring variables. Okay, variable. So you first put the type of the variable and only the name of the variable. Okay. Implicit none. So what the hell is implicit? Do they even explain what the fuck is implicit? Always use implicit none statement at the beginning of each program and procedure. Implicit typing is considered bad practice in modern programming since it hides information leading to more program errors. Implicit typing, so... Oh, it had like an implicit typing. Alright. So is that it? Is there any more information on how to... Right. So note the additional statement at the beginning of the program, implicit none. This statement tells the compiler that all variables will be explicitly declared. Without this statement, variables will be implicitly typed according to the letter they begin with. What, like... What the hell is this language? Is this like an intentional joke or... Like... What the fuck is this shit? It doesn't make any fucking sense, even by the standards of 70s. It's like a... It's a... Fuck. Is this an intercall? This is an intercall joke, right? You know, the language that is like esoteric language that is intentionally designed to piss you off. That's one of these languages, right? This could not be a real programming language. Right, it's just like, it's just to piss you off. It's, oh, it's from 50s, yeah, I'm sorry. Right, so it's gonna be typed according to the first letter, and it may not work on Tuesdays. Because fuck you. That's right. So, it's one of this language, it must be. Right, it must be one of this language. And people unironically write shit in it, like, what? Okay. So that is very interesting. So, what that means, let's actually go here and see what's going to happen. So, we can define an integer amount. Right. Is it going to work if we try to... Okay, so it worked after we tried to compile it. I wonder... if I can just put amount in here without any initialization. Okay. And it's different every time, because it's not initialized. Alright, that's already something. Can I now say that amount is a 69? I can. Wait! Why does it always put the spaces in? Does it try to fit this entire thing into a certain width? So this is 12 characters, and if I... how do I comment out things? If I put hello world like this, it's 13 characters. Right. So it's 14. So it tries to fit it into a certain width, probably. Like. Alright. So this is the amount. Okay, and here is an interesting question. So what if I just like remove the definition of the type? Is it going to work? No, it doesn't really work. Right, because how do you do dynamic implicit typing? How do you do implicit typing? Do you just like say 69? No, this is not how we do that. I'm really interested. So they're telling me don't use that feature, it's bad. You know what that means, chat? You know what that means when somebody tells you don't use that feature. You know, right? You fucking use it, right? So Fortran implicit typing example. So I want to see how this feature works. Why the fuck do you tell me not to use this feature? Fuck you. I'm gonna use it, right? So I want to discover myself why it is bad. Right. Imagine somebody telling you how to write your programs. This fucking casting. Alright, so you just do... Alright, so you essentially do it like that. Easy peasy. And it recognized it as float. What if I put like S in there? It's still float. Oh, I mean, it's still float, yes. How, like, what does it correspond to? What does it correspond to? Is there any table that actually tells you what these variables mean? right? Depending on the first. So they say that it depends on the first character. Variables starting with X, Y, and Z are complex. Variables starting with C, S are characters with lengths of 4, and all other letters have have their default implicit type. So if I call this thing X, it's not particularly complex. What if I say it's C? Huh. Ah, X. So you have a bunch of implicitly defined variables for you already. Right. Yo, I see what this feature is about. Implicit none? Is that how we do that? Yeah. Yeah. So essentially, by default, Fortran gives you a bunch of predefined variables that you can use, and they have predefined types. This is kind of cool, actually. This is kind of cool, isn't it? Right. Right. So if you're doing math stuff and science stuff, you're quite often going to predefine X, Y, and Z with the same type and stuff like that. There's something to that. Well, I mean, I can see why people may not want to have this feature, right? I can see why people may not want to have this feature, but at the same time, if you use this language as sort of like a specialized language for like science computing in 50s, it does kind of make sense, right? Especially if you writing shit in the punch cards, right? So you just like don't want to spend too many characters. But if you want to actually write compact programs, why would you have such a long like keywords and stuff like that? So it also doesn't make any sense. But I see what it's all about, right? So I see what it's all about, and I see why people may not want to have that, right? But it was important to try that feature out. I think it's important to try that feature out. And they say that it's about the variables that start. So that means I can say X, your mom, and if I remove implicit none, it will work. So it not only predefines a bunch of like variables, it predefines anything that start with these specific characters and stuff like that. But what if I do just like your mom? Oh, it always predefines. I see what's going on. Right, so I see what's going on. Right, so C. Yeah, it still looks like that, but okay. So now we know why you should probably do implicit none, right? So now we do kind of understand. So I'm going to put that in the description, in the references. So this is one of the things. reaptutorial.com. reaptutorial.com. I'm pretty sure all of that is generated by ChatGPT, right? So all of these websites. I think we need to acknowledge some subs, chats, right? So we've got some subs. Let's quickly acknowledge all of these awesome people. So where is the, so 22 minutes ago. All right, Fabio HBF, thank you so much for tier 1 subscription. Sustained Cruelty, thank you so much for Twitch Prime. Akoya here, thank you so much for tier 1 with the message Fortran stream better than Fortnite stream. I actually never played Fortran, I don't think it's gonna work on my machine. Marks77, thank you so much for Twitch Prime, and Yoink2000, thank you so much for Twitch Prime with the message Atsoding Apoging. Okay, so yeah, we want to just do implicit none, and then we want to define shit like integer x, and then we want to print x, and then we want to initialize x with 420, and everything seems to be working. So I'm getting the gist of this language. I think I'm getting the gist of this language. Fortran code is case insensitive, just like Pascal. Alright, that's cool. Standard input output. Okay, so this one is interesting because I really want to understand how the formatting works. In our Hello World example, we're writing text to the command window. This is commonly referred as the writing to standard output or stdio. We can use the print statement introduced earlier to print variables values to stdout. Okay, so we already figured it out, so there's nothing new in here. But I wonder if we can do something like x, right? And is it going to like actually yeah, it is going to like format it in a certain way, right? I was kind of expecting this thing to do that. Integer y, and I wonder if I can do this kind of stuff, right? 69 for 20. So then I can say something like this. Can I do that? Yeah, I can. This is actually kind of comfortable if you think about it, right? I can see myself using that for some scientific computations. Not bad. Can I also like automatically initialize this kind of stuff? So it doesn't like some... yeah, you can't do it like that. All right, so that's fine. So we can initialize it. Not bad, not bad. So in a similar way, we can read values from the command window using the read statement. Aha! Please enter your age. Your age is... This is like basically software 1.0 example of that neural network that tells you your age based on your age. Do you guys remember? There was this is my favorite meme, but somebody was training the neural network to basically predict your age based on your age, and it had like a 98% of like success in doing that. This is basically that, but from the previous century, right? So you can tell somebody's age based on the 97% accuracy. But this one, by the way, is going to have 100% accuracy. So even though that approach is using artificial intelligence, it's actually less accurate than the previous age technology. So we're literally going backward. We're literally going backward. All right, so let's actually try to write this program. Right, so I'm going to do age F90. Program H and program H. All right, so, and we're gonna say implicit none. Implicit none, I'm gonna define the H, which is an integer. I do have a reflex to actually put type after this entire thing, but you have to put it here first. All right, so, and let's actually print something like, hello, what is your age? And then we have to what the why? I still haven't figured out why you have to put star in here, but now here you have to put double star, and it's just like, what is all of this shit? What is all of this shit? Oh, people asking how did I swap the words. Can your Vim do that? Can your Vim do that? I don't fucking think so. Haha. So essentially what I pressed Alt, basically MT. Right. So we can even take a look at the bindings. Right. If you press Alt T, this is transpose words. So this is a standard Emacs function, and it transposes the words. I wonder how many other functions that start with transpose we have. Transpose. You can transpose words. You can transpose sexps. You can transpose regions. That is actually kind of interesting. So let me just put something in here, and I'm gonna maybe have a couple of transpose regions. I mean, transpose. No, I thought transpose paragraphs. We can transpose lines. Yeah, there's transpose lines. But why are you trying to say transpose regions? Transposed regions overlap. Can you have several regions? Is that a thing you can do in Emacs? I didn't know that, but I mean, that's not the point of today's stream, but that's rather interesting anyway. Alright, so we have to do this weird Scheiße read, and we have to read the age, and then we can say print your age is age. Okay, let's find out if it's going to compile. It didn't compile. Oh, for fuck, don't fucking tell me. Don't fucking tell me that program age introduces symbol age. Dude, don't freaking tell me that you fell into the same trap as Pascal. Dude, don't. Yes, it is like Pascal. This is so dumb, and this is something that I don't like about Pascal, right? Is that you may have a program main, right? So maybe even, I don't know how to say that, maybe program foo, and let's call it pass. And you have to specify a program. And if you used program foo in here, you literally unable to have a variable foo anymore. Like, you can't do that. You're not legally allowed to do that because somehow this thing occupies a symbol even though you never fucking use that symbol anywhere. It's not like it's a module to which you can refer and stuff like that. No, it's not really, you're not really referring to a program, but it's still goddamn, I don't know. I have no words. I'm losing words. Why? I have no idea. It's just like people from 70s and 50s decided so. We don't really know their reasoning, but they just decided so. Anonymous program. Is that possible to do? Let's actually see how it works. So we can do fpc foo.pass and a duplicate identifier foo, right? So at least it tells you precisely what's going on. And the only reason why I managed to code that in Fortran is because I kind of had a similar situation in Pascal, right? So this is really weird. Maybe you are supposed to refer to this thing, but I mean, how? It's not a module. It's not a unit. I think they're called units in Pascal. Weird as scheiße. All right. So let me see. So this is your age. I think it would be easier to actually interact with the program in a real terminal. Know what I mean? Know what I mean? Let's go. 69, your age is 69. I really don't like this like formatting, like a lack of control over formatting. I think it's kind of dumb. All right, but we managed to identify the age. But what if we make it a little bit random? Fortran random number. How do you do a random number? Okay, so there's a GNU Fortran random number. There is a function, random number, returns a single pseudo-random number or an array of pseudo-random numbers from the uniform distribution from 0 to... Oh, right, so it's probably floats. The runtime implements Soshiro 256. Pseudo-random number generator. It's kind of interesting. Why does it return either number or array of pseudo-numbers? Like, how do you decide? How do you decide what exactly do you return? So there's no really return value in here. Call random. So this is not the definition though, right? This is not the definition. So you can do a random init, initialize a random number generator, initialize number sequence and stuff like that. Okay, so let's actually go to main 69. So this is where we were sort of like playing with all of this thing. And we can say something like random equal to random number. And yeah, you're supposed to just... Oh, you're supposed to use call. Wait a second. It doesn't return shit. It accepts the return variable. What the fuck? So that's really interesting. Okay, can I do something like random number? And I have to, yeah, so it even highlights this entire thing, X. And it also says that you have to do call, but I wonder if it will work without that. So it's gonna be X, something like this, and it's gonna be X. So, and let's try to build main, and let's just try to run it. So random number, yeah. And classified statement. So, why we accidentally, so it has to be classified. I mean, call. It has to be classified. All right. Harvest argument of the random number must be real. Ah. Yo! Wait. Do they really... They call a return parameter of a function harvest. They really call it harvest. Holy shit. This is so funny. It's like when you have a function that searches something within an array, right? So the array, the argument that accepts an array is called haystack, and the thing that you're searching in that array is called needle. It's similar to that. The return parameter of the random thing is harvest. You're harvesting it. The original computer scientists were farmers, not mathematicians. Yeah, exactly. That's probably the reason. Yeah, because it also explains the haystack and needle. 50s programming were strange people. I mean, yeah, they were different, I suppose. But it's kind of fun. It's kind of interesting, is it not? I think it is. I think it actually is. Anyways, so it has to be a real one. And it's kind of funny that, like, if you want to call it, right, you can't really use this function as an expression. It's really very much not an expression-based language. It's basically statements and statements upon statements. It feels like there's not that many expressions in there, except maybe mathematical expressions. Alright, so what if we do something like 35 and 34, and then I say nice is equal x plus 9, is it going to work? Yeah, it did work. So maybe mathematical expressions are expressions, but calling a function is kind of like a statement. It's kind of weird. Alright, so in essentially what we have to do, if we want to sort of randomize the age a little bit, right? If we want to randomize the age, we probably need to have a random parameter called error, right? So this is a random parameter called error. And we may just generate a random number with the error that we can add to the age, right? So from time to time, this entire thing is gonna basically return you incorrect age, right? So because we want to mimic the modern technology, right? So the modern equivalent of this program would be a neural network that you train with basically like recognizing the age based on your age, but it's not going to be always 100%, right? If it is 100%, it's an old-ass technology that nobody gives a fuck about. It's a boomer software. Only boomer software actually being accurate and stable. The modern zoomer software is supposed to be inaccurate and faulty and buggy. You know what I mean? If your program is fast and stable, nobody gives a shit about it. Like, I mean, it's a boomer program. Like, who writes software like that? Right. So to mimic this, you know, the modern software practices, we need to introduce an error into the... Determinism is so 20th century. Exactly. Chat knows what's up. Chat knows what's up. Exactly. So who needs determinism? All right. So I'm a little bit afraid that it's going to essentially error out because maybe integer and real are not compatible with each other. This is actually very interesting. Is it like weakly type or strongly type? Does it allow you to do mathematical expressions on integers and reals? So we're about to find out. So we're about to find that scheisse out. It does allow you. Well, I'm not surprised. It literally does allow you to add up integers and floats, and I wonder what is it going to print in that specific case. So let's actually run the h, right? So I'm going to say a 69, and of course it basically converted all of that to float. But I wonder, what if I do something like age equal age plus error, right? Because we know that age is integer. This thing is going to add them up, which will turn it into float, and I hope that after assigning this thing back to the age is going to be truncated into an integer, right? So let's actually go ahead and try to do that and run this entire thing. I'm going to say 69. It was truncated to an integer, so it actually, from the semantical point of view, it acts like C, which is not particularly surprising, right? So it's both of them are old languages. To be fair, Fortran is even older than that. So yeah. But the problem here is that the error, right, so the random number is from 0 to 1, right? It is from 0 to 1. So it's not always going to introduce that specific error. I think what we need to do, we probably need to multiply that by 2, right? So it becomes from the range from 0 to 1 to 0 to 2. So that means from time to time it's going to actually return you 70 or something like that, right? So this is basically an error. All right, so let's go ahead and try to do that. My age is 69. Okay, if I try to do that one more time. Sometimes it returns 70. Sometimes it returns 70, but sometimes it's going to return 69. So you never know. It's random. It's absolutely random. But it's actually in a positive range. It would be nice if it also sometimes went down. You know what I mean? So we have a range from 0 to 1. Here, to actually have an effect, we had to map it to a range from 0 to 2. So to have an effect in an opposite direction, we have to map it to a range from 0 to from -2 to 2. From -2 to 2. How can we do that? Right, first of all, we can try to multiply this entire thing by 4, which will turn it into a range from 0 to 4. Then we can try to multiply, basically subtract 2 from this entire thing, which will turn it into the range from -2 to 2. Right, so that's basically how we can achieve this entire thing. We need to multiply by 4, and then we have to subtract 2. And that's basically how we can achieve that. So it's going to round up and down, and hopefully it will mimic the real modern software, finally. Alright, so it's going to be 69, 70, 69, 70. I wonder when it's going to go down. Does it even go down? I'm actually really surprised. So maybe we need to... maybe we need to debug that, or like for how long do I... Okay, 68. Alright, 68. So sometimes it goes down, so it's not being reliable. Right, so 67, that's actually pretty rare, I think. 69, sometimes it's actually... Okay, that's cool. So that's pretty cool. I really like that so far. So let's continue learning these traits. Read. I really want to understand this entire thing. So we have a tutorial in here. Not really tutorial, but manual. I wonder if we can find the list of all of the procedures in here. Okay, so do you have a print procedure? Okay, it's not particularly a procedure. Right, because you don't really call print. That's the thing. So random is an intrinsic procedure, and that's why you call it. But print, you never call print. It's a built-in statement. So that's why we probably won't be able to see read and print in the list of all of the available standard functions, because fuck you, it's not a function. Okay. So maybe there is a list of constructions. So intrinsic modules, introduction, compile option, runtime, influence runtime behavior with inherent variables. We don't care about that. Compiler characteristics, extensions, mixed language. Can we link with Raylib and make a fucking game in Fortran? Easy peasy? Lemon fucking squeeze? Oh, holy shit, we could probably do that. Let's actually see. So intrinsic type, okay. This is boring, bruv. I think I need like a specific, okay, so here's, I saw C binding. The fuck? My type. Oh, this is basically structures. This is how you define the structures, so they pad it like the C structures. Interoperable. Working with the C further interoperability. This is very dry. This is just like, you know, a dry example. Like, this is what you can do. Here is the standard. Read the standard, blah, blah, blah. So there is no particular example that we can just quickly copy paste and implement a game, so fuck that. So why am I here? Just to suffer. I just want to see like how do you work with print. Type it as an alias for print. Yeah. Anyway, they won't tell us how the print works. Okay, whatever. So expressions. So it does have exponent. Would you look at that? So it's like Python. It's a Python from 50s. It's a Python from 50s. So expressions. Okay, so expressions pretty straightforward. Like I don't see anything particularly special. Floating point precision. The desired floating point precision can be explicitly declared. So, oh, that's actually really interesting. So you can like specifically decide what you want. Interoperables kind. All right. Arrays and strings. Let's take a look at arrays and strings. More often than not, we need to store and operate on long lists of numbers as opposed to just a single scalar variable that we have been using so far. In computer programming, such lists are called arrays. Arrays are multidimensional variables that contain more than one value, where each value is accessed using one or more indices. Arrays in Fortran are... I need to make a small break. Yeah, so I need more tea for this shit. I need more tea for this shit, so let's make a small break. Alright, so let's continue. I have my tea, so I have everything, and let's go ahead and do that. So let's read how to use this abomination. Arrays are multidimensional variables that contain more than one value, where each value is accessed using one or more indices. Arrays in Fortran are one base by default. This means that by default, right, so that means you can change that. This means that the first element along any dimension is at index. Oh, by the way, maybe we can actually make it... Why didn't I do that earlier? I'm sorry. Array declaration. We can declare arrays of any type. There are two common notations for declaring array variables using the dimension attribute or by appending the array dimensions in the parentheses to the variable name. Static array declaration. Okay. So essentially we say integer dimension 10. Okay, so basically this thing modifies the previous type. Or equivalent array declaration, so yeah, we're declaring it on the level of the name. And then you can have multi-dimensional thing in here. Alright, that's cool. So custom lower and upper. Okay, so here are lower and upper index bounds. That makes sense. That's actually kind of cool. And let's give it a try. So here's the main. Maybe I'm gonna call it nice. Right, so this is example which is nice. It just like defines two variables, sums them up and prints them, and this is just basically hello world. This is age, right, so this is age. And let's introduce something else. Let's call it arrays maybe. F90 program arrays and program arrays. And let's maybe define some stuff. So we want to probably, I want to define like a real and the dimensions. Let's actually say that we're going to have 10 of those things. So, and we probably want to do implicit none. And one of the things I want to do, I want to just like literally print this entire stuff without any initialization. Right, let's not even initialize anything here. Arrays, I want to also specify the output variable in here, not variable, but name. And let's actually print it. So it gave us bullshit, right? So it's a garbage from the stack. It's a garbage from the stack. I think 10 of them is too big because I can't see them on the, on the screen properly. I think something like 5 is a little bit better. And I suppose it tries to like pad them to the same size, which is fair enough, Let's try to call RandomNumber. And if I remember correctly, according to the documentation of RandomNumber, so here it is, RandomNumber documentation, it returns a single pseudo-random number or an array of pseudo-random numbers. So I suppose I wonder how does it decide which version to call? How does it know which version to call? I would like to see the definition of random number. I would like to see the definition. And yeah, that looks actually kind of cool. So it's from zeros to 1. So does it have array operations like in NumPy or R? You know, R programming language. There's such programming language called R. Like in that programming language, you can take an array and multiply it by 10, and it will multiply each element by 10. Is that... Did you just fucking guess it? You can do that. It's just like, okay. Okay, I see why people may use it for like scientific computing. All right. So, yeah. That's really interesting. So, essentially, yeah, it's basically like R. It feels like a mix of C, Pascal, and R so far. Yeah. C, Pascal, and R. Like, I can see the ideas, like how people got inspired by different ideas in different languages. But I suppose Fortran, since it's the oldest language, kind of initiated all these ideas, right? So essentially, it's probably the other way around. It's probably the Pascal, R, and NumPy got these ideas from Fortran. Right, so they probably got all these ideas from Fortran. Okay, that's kind of cool. I like that. Right, so the experience of learning Fortran so far is very educational and informative. Right, I really like that. So the only thing I'm really worried about is that how do they determine at compile time which version of random number to call? Do they determine that at compile time, or do they determine that at runtime? So is the size of the array stored at runtime so random number can inspect you know, the dimensions of this thing at runtime? Maybe there's this thing, this is just a hypothesis, that any variable in Fortran is an array. It's just like if you define real x, it's basically considered an array of a single number. Array of a single value of element. Jesus fucking Christ. Right. It's considered an array of a single element. That's what it feels so far. It could be true or it could be not. I don't really know. I know nothing about Fortran. I'm basically hallucinating, you know, features of the language, just like ChatGPT. Right. I'm just like using my previous experience to hallucinate things about the language. Like I don't really know, but it feels like it could be true. Right, so maybe like everything is an array, it's just like this thing is implicitly array of a single element, implicitly. And that's how random number knows how to like generate for a single number and for arrays. It just like has one implementation to generate random number for arrays, and like single variables are just arrays of single numbers. So yeah, that could be the truth. But I would like to see the definition. There is no definition in here. I mean declaration, signature of this stuff. I wonder if we have some stuff in here. So do we have any Fortran things in include? Do we have any Fortran things in include? So if I try to find file F and name, I want the name to end with F and some extra stuff. Is there something like that? I don't think there are such files specifically in user include. I didn't think so. Yeah, there's no such thing. Maybe in user share we can find some files that contain the name Fortran. Just like anything that contained the name Fortran. Can we find anything? Okay, so, and Vim, primarily Vim stuff. Lintian. So I'm searching in user share. Okay, I found something. I don't know what is a lintian. It's probably some sort of a linter. Does anybody know? I don't even know what I have installed in here, right? I don't even know. Lintian is a helper tool used in conjunction with dpackage. Oh, okay. TechLife. All right. So this is just like the other stuff. Code blocks. Cock blocks. I don't think it's Yeah, I don't think it's gonna be anything particularly useful in there. Maybe it's somewhere in libs, or maybe it's somewhere in local. So this is docs. Find file. Okay, so there are docs Fortran. Find file at point. So there's some docs in here, but I don't think it's particularly useful. No way we're learning Fortran. Well, you think I'm joking? You think this is a motherfucking joke? We're fucking learning Fortran. The only thing I need to do, I need to find the Fortran files on my machine, and I can't do that. They don't exist, at least in user share. Maybe I have to go a little bit higher, but I'm not sure where exactly do I have to go. Let's try to find like at user, right? Like straight up at user. It would be kind of cool if essentially I could say search, what the fuck, search G Fortran. Is there any way to give the name of the package and get the list of all of the installed files? I remember the package had something like that. I do remember. Right, so can I just give the package this name and the package would tell me the list of all of these things? Does anybody remember the command? Does anybody remember the command? So we have Fortran here, so here's the share. We know that in share there is nothing particularly useful. So it goes into the local. Crack Fortran. Crack Fortran, yes, it is a thing in here. Crack Fortran, it is a thing indeed. So essentially what I'm trying to find, where I have like the standard library of Fortran, so I can just look into the okay, the package L, the package -L G Fortran 8. Okay, that's perfect. Thank you so much. What do we have in here? So it is like okay, it is located in lib. So libc. It could be maybe actually located in different packages. So if I do G Fortran, there are a lot of things like libgfortran, right? So there is a libgfortran 8def. Yeah, so this is probably what we want to do. The package L libgfortran 8def. But it doesn't contain the sources. Maybe there is no such thing as sources in there. Maybe there is no such thing as sources because it doesn't have headers like C. Does it? I don't think it does. Right, so it basically just looks into the symbols and whatnot. Probably not, I don't know. But essentially what I want to be able to do. So there is no such thing as F90. There's some F90 files, but not that many of them. So yeah, that's kind of sad. Do we have a G-Fortran source code? I suppose we have to download the source code of G-Fortran. GCC FTP website. Is it possible to access that from HTTP? Who uses FTP in 2023? Just HTTP. Okay, I can do that. So the latest releases were, it's not even sorted by last modified date, so let's actually sort it. There we go. So this is the latest stuff. This is, oh, it's part of the GCC. God damn it. It's part of the GCC. So we can't have that. Is there a GCC mirror anywhere? GitHub GCC mirror. All right. So there is GCC. And there should be Fortran. Oh my god. Dude. Freaking... I swear to god, GitHub. Sorry. Okay, libgfortran. So there's something like... It's just a glorified file hosting. Like, it has no business to be this fucking slow. Like, come on. I don't fucking know, seriously. Intrinsic, so maybe this one is interesting because I remember the alright, random number. It doesn't have a random number. Fuck. So this is not an intrinsic thing. This is not an intrinsic thing. Alright, so one of the things I want to do, I want to maybe clone the source code of GCC to quickly just find this stuff. Because using GitHub is unbearable. It's truly unbearable. We're gonna clone this entire thing, but we're gonna use the depth one so it doesn't clone like literally everything. Right, so all the entire history. Hopefully it's not gonna take too much space, because even if we're like downloading the latest snapshot, it still can be relatively big. I could have just downloaded that tarball from the FTP. Speaking of open source, right? The modern version of closed source. The modern version of closed source is an open source that is so big and convoluted, nobody wants to even look at it and even download this shit. That's the basically modern version of the closed source, right? So that's how basically Chromium, I think, also closed source. It's so fucking big, so convoluted that it's basically gatekeeps itself. Depth 1 is the way. It is depth 1. That's my friends. That's the fucking problem. It is depth 1. Zorzin, just use depth 1. Well, I have bad news for you. I have bad news for you. It is a depth 1. So GCC. All right. So what do we have in here in terms of Fortran? Grep Fortran. Okay, so there's only lib g Fortran. Can I just go there? Yeah, there we go. Grep random number, and we know that Fortran is a case-insensitive language, which makes it absolutely perfect for grepping. We all know that. But luckily, in the grep we have like a I flag, which okay, so there's no such thing here. Is it like a really random number? Yeah, it is called random number, so there's no such thing. Okay, so let's try to do this thing. Okay, so we found it. We instantly found it actually. So here it is. str ASIN. It's actually call. Right, so it's actually call. So it contains a lot of things, but we can't really find the declaration. Oh, there is a GCC Fortran. I found it. There we go. So there's a GCC Fortran, and I wonder if within this thing we can find a file which name contains random number or something like that, or maybe just random. No, there is no such thing. Okay, but there should be something like random number with I. Let me maybe go with Emacs. Right, I want to do that with Emacs. It's a GCC Fortran, and essentially I want to grab it like this, random number with I. So then later I can actually jump to all of these places. So it's an intrinsic CC. It is probably implemented. It is probably implemented in C. So there is no like a declaration like of this thing. Okay, I see. This is so funny actually. I resolve a random number, and in there, if we take a look at the intrinsic, so this is a macro, right, that defines this thing, and this is the functions that probably implement that. So there is a check random number, GFC check random number, and GFC resolve random number. So this is probably the functions that we care the most about. Right, so the answer, I suppose, is that this thing is just implemented in C, so that's how it works, basically. So I want to take a look at the check random number. So what is it all about? Check random number, where's the implementation? So here is the implementation. Check the harvest. Okay, that's very interesting. So it's type and variable check. If it's not real, it returns false. So this is basically type check, but is it called at runtime? It might be actually called at runtime, but it could have been, yeah, if it is intrinsic. Yeah, if it is intrinsic, it could be like a part of the compilation or something. But yeah, check resolve random number. Right. So, and let's take a look at the implementation of this entire thing. I resolve ABI kind resolve get intrinsic subsymbol name. Right, so then it calls even further to something else. Okay, so it goes too deep in C. So I don't think we can literally like find the definition. It might be just like built in. It could have been just like a built-in intrinsic thing. Right, so intrinsic procedures. Intrinsic procedures provided by GNU Fortran include procedures required by Fortran 95 and later supported standards of intrinsics. Any conflict between description here, description in the Fortran standard is unintentional, blah blah blah. Yeah, I feel like they're built in. Right, I feel like they're built in. So the thing the question that I was trying to answer is that, is it like defined somewhere in a standard library, or is it like built into the compiler? And I think it's built in because we found like literally C code that implements all of that stuff. Okay, that's very interesting. I mean, that's fine. There's nothing wrong with that. Okay, so where is this thing? So this is arrays. We call random number, we multiply them by 10. So let's go back to the arrays and stuff like that. So Fortran array, have this array, and there we go. So that seems to be working, and then we can call arrays, and here they are. So that's pretty cool. Arrays slicing. Holy shit. Okay, a powerful feature of the Fortran language is its built-in support for array operations. We can perform operations on all or part of an array using array slicing notation. So array constructor, you can just like literally assign this entire thing. Implied do loop constructor. What the fuck? So are you telling me? So this has to be an integer. So I can define a bunch of x's in here, and then I can say, okay, x's is equal to like I, where I is between 1 and 10. This is some of the flippin' list comprehension from Haskell, isn't it? They stole it from Haskell. Well, it doesn't even work. It doesn't even freaking work because x's, well, x is supposed to be symbol I is implicit. Oh, if you want to use this symbol I, it has to be defined like this because it's an implicit loop. Hello, Freeform. Hi. All right. So a different shape of an array, an assignment, and this is because it's from 1 to 5. So we have to do something like this. Would you look at that? Who needs Python? It's even more compact than in Python. Right, in Python, how do you do that? You do I for I in range 5. Like, what the fuck is this shit, bruv? Bruv, look at that. Chad Fortran. Holy shit. Fuck Python. Finally, we have the Chad language. Mein Gott. Okay. So, and you have slices just like in Python. This is literally Python from 50s. This is literally Python from 50s. So, and can I do some stuff like, I want to take values from 1 to 3, maybe, right? So don't print everything. Didn't really work, right, because it has to be parentheses. I'm sorry, I apologize for my mistake. I made a severe lapse of judgment. Print out the first column, right, so Yeah, there's a lot of interesting things here. Allocatable dynamic arrays. You can even work with dynamic memory. Allocatable. My God. Submissive and allocatable. So you can actually work directly with the memory. That's pretty cool. So far we have specified the size of our array in our program code. This type of array is known as static arrays since its size is fixed when we compile our program. Quite often, we do not know how big our array needs to be until we run our program. For example, if we are reading data from file of unknown size, for this problem, of known size, end of the sentence, I'm sorry. For these problems, we need allocatable arrays. These are allocated while the program is running once we know how big the array needs to be. Okay, so but why do you have to explicitly say that it's allocatable? Probably because it stores it as an pointer to a heap under the hood. That's why it needs this additional flag to distinguish them. So allocatable basically turns it into a pointer to an array or something. I don't know. Okay, so then you can allocate array 10. Not good enough. Character strings. Alright, so this one is interesting. I think this is the most interesting part, right? So let's actually write a program which is kind of similar to age, but instead of asking your age, it asks for your name, right? It asks for your name. Basically, it says like, hello, what is your name? And I say my name and it says, hello, that name, right? So this is actually kind of cool, I think. Let's go ahead and try to implement that. So, and that's literally what it is, right? So, I mean, it's just first and last name or something like that, but it's fine. So we allocate, we create first name, which is 4 characters, last name, blah, blah, blah. And we just print all of that. But can we read this entire thing? That's the real question. We can allocate this entire thing. It doesn't really tell us if we can read that or not, but we can just try. So let's go ahead and do that. I'm going to create a name, which is F90, program name, right? And we're going to end the program name. We're going to do implicit none, right? Because no implicit variable definitions. And let's introduce the name. Unfortunately, we can't really use the name because it's already freaking taken by the name of the program. I swear to God, all of these languages from 50s and 70s, we have to say, what is your name? Can we do something like that? I'm pretty sure we can do something like that. Okay, so then it allows us to define a character, which is a name, and I suppose it has to be like len. And let's say that 69 characters should be enough for everyone. I think that's how you do that, right? So it's just len equal, and these two things are equivalent, right? Len equal 5 or just like len, just 5 are equivalent, I suppose. Okay. And after that we can print something like, hello, what is your name? And we're going to read your name. I'm gonna literally assume that I can just use read on this thing and it's gonna literally read it. That's my assumption. Then we can do something like hello name. All right. Hopefully that will work. I hope it's not gonna pad this thing like so, but we'll see. We'll see. All right. So I'm gonna replace it with name, and then I'm gonna just compile it. It compiled first try. I'm becoming the Fortran master. Fortran master. Yes, Pogue. So let's go back to probe. I can't delete that. Fortran. And let's do name. Easy peasy, lemon a fucking squeezy. So I forgot to put a space in here, so we can do that one more time. Where are the pogs in the chat? Where are the pogs in the chat? First try, got clear. Okay, that's cool. That's actually pretty cool. So we can work with all of that. So there's also allocatable character. I don't know what the fuck is this thing. Like, why do we have to put colons in here? I'm not particularly sure. But you can just basically allocate these things. You can have arrays of strings. An array of strings can be expressed in Fortran as an array of character variables. All elements in a character array have equal length. I see. I see what you mean. Okay, so that makes sense. So, yeah. So I think I know how to work with that. It's reasonable, I think it's reasonable. Operators and control flow. Operators and control flow. You know what? I think I'm ready for something serious. Like, I'm kind of bored with all this lecturing of like, here's how you do that, here's how you do that, remember that, remember that. Fucking boring. Boring. We need to have something substantial. Let's try to link with Rayleigh. Or let's try to write a function in C and link with that function in Fortran and call that function. Like, we can learn all of these constructions along the way, right? Like, all of that, like, who wants to like sit down and just memorize all of that stuff for nerds? Nobody wants to do that. Right, so let's go ahead and just like write, I don't know, maybe something like foo C. And here we're gonna have void hello. And in here we're gonna say print f hello from C. That's it. Can we call this function from Fortran? And if we can, we basically win. We basically win. All right. So I want to clean up some of this stuff. So I think I'm going to remove GCC. So it actually takes some time to remove this goddamn folder. So, because the folder is so huge that it needs some time. And unfortunately, in Emacs, it doesn't show the progress, because I run it in a way that if the command blocks, it also blocks the entire Emacs, like for the entirety of the command. So I can actually cancel it. Right, so let's go ahead and maybe do that like this. Yeah, there we go. So it's gonna take some time to remove this GCC thing. It's actually kind of fun. All right. So let's remove all of these binaries. I just want to clean everything up. Arrays, age, and foo. So let's introduce build sh and simply build all of these things. I'm gonna bin sh. Why did you quit Emacs? I don't know what it's doing. G Fortran. O, maybe just arrays f and o arrays. So the first thing we're gonna have in here is probably just nice. Then we have age, then name, and then arrays. Right, so we have just like a bunch of examples in here. Another thing that we want to build in here is probably foo. So I'm gonna assume that I can do something like this, and then create an object file. Can I create an object file out of this stuff? Okay, so printf, it probably wants something like stdio, and it should have created an object file. Can we link with that object file? So let me see. We can Google up Fortran, or maybe G Fortran C interop example. I want to see some example. We already actually looked into this thing, but I want to like an actual example that I can test out. This is useless. This is straight up useless. So interoperables, subroutines, and functions. Subroutines and functions have to have the bind C attribute to be compatible with C. The dummy argument declaration is relatively straightforward. However, one needs to be careful because C uses call by value by default, while Fortran behaves usually similar to call by reference. Furthermore, strings and pointers are handled differently, so you have to be careful with that. Luckily, by the way, the cool thing about Rayleigh is that it doesn't really accept that many arguments, in the sense that, right, you initialize the window and you just have to pass the size of the window, but it doesn't return a pointer to a window or anything like that. It just like stores everything in global variables, right? So you actually, RayLib tries to reduce the amount of like passing of information between program and library to minimum, which makes it a little bit easier to work with from other languages, which is kind of a five-head strategy on the RayLib side, I think. I think it is. Oh, by the way, so we have some sub that I didn't acknowledge. I don't remember if I acknowledged. Selko says, thank you so much, and Hector84, thank you so much for tier 1 subscription. Thank you guys. All right, so how can we do all of that? So matches the Fortran declaration. That's very interesting. So let's actually create something like foo f90, and we're gonna create a program foo. Right, and program foo, and we're gonna just print. Of course, we're gonna do implicit non print hello world. Print hello world, and let's maybe build this entire thing in here as well. So if we do g fourth, come on, foo. Let's not build any of this stuff. And it gave us the executable, and if we run this executable, it is hello world. Okay, that's fine. I also want to set xe so it logs all of the commands that it actually runs. And can we literally copy paste this entire stuff to our full program? Can we literally copy paste it? Do we have to copy paste it outside of the program or inside of the program? This is a very interesting question. So this is, I suppose, a return type. If we take a look, we accept and return void. So maybe we can just do literally void, and it doesn't automatically highlight this entire thing, unfortunately. So can we just say, maybe we have to say that it's a subroutine. Yeah, maybe that's precisely what we have to say. So ISO C binding, only C ints. I have no idea what these things are. So maybe we have to do it like that. Okay, so then I'm gonna try to build this thing one more time, and it complains by saying unexpected program statement. And yeah, I can see that. All right. So probably we have to move this thing inside of this subroutine declaration. No, it's not how it works. It's not how it works, unfortunately. And this example is not complete. This example is not complete. All right, so maybe we need some sort of a complete example. This is like straight up useless. I don't like when they give you like a half-assed examples that you can just copy paste and compile and try. It's always like you have to guess what else you have to print in there. Like it's just like, fucking no, give me the full example so I can try it. Is it that hard? No, you have to just like, you know, give me like portions that I have to stitch together myself. How is that a useful documentation? I have no idea. Well, we can try this kind of stuff, right? So this seems like a full example. Like how I was supposed to know that you have to wrap it in an interface? Why didn't you tell me that I have to wrap it in an interface in here? Like why do you put it like... I'm sorry, I'm just like disappointed when I read such a low quality documentation. It's straight up low quality documentation, and I'm tired pretending that it's not. I'm really tired pretending that it's not a low quality documentation. It's straight up is, and there's nothing you can say to convince me otherwise. I'm sorry. All right, so let's actually go ahead and maybe like copy paste the whole thing, and yeah. Fortran gatekeepers, yeah, exactly. They're gatekeeping everything. They're pretending like you have to have a PhD to understand all of that. In reality, it is very, very dumb. It's just convoluted intentionally to keep you away from all of that. It is convoluted intentionally. And it's not your fault if it doesn't work for you. It's not your fault. They're doing that intentionally, those goddamn gatekeepers. Okay, this one is interesting. Okay, so use ISO C. Oh, okay, this one is interesting. So it's like importing a module. So ISO C binding, yeah, it's like import, and you importing only these things. Okay, that's cool. Then you define an interface, and within an interface you define these declarations. Right, so it accepts a string, and you bind C name print C. Okay, so that's cool. And then in ISO C binding only C char, and okay, that's cool. And you end all of that, and then you call hello world and everything. So that's very cool. So if I take a look at for C, from C code, I'm going to put it like that. So now I'm going to try to simply compile this entire thing, and it's not supposed to compile whatsoever. Okay, that is very cool. Implicit none, it didn't really work like that, because you probably have to put this entire thing outside of the program. Again, halved as example. Halved as example doesn't tell you like where exactly you have to put that stuff. Why are they like that? Like, why don't you just give me the full goddamn example? What is wrong with these people? Oh god. Right. It's just like, dude. They're just like trolling you. They're literally trolling you. This is not a full example. And they're not gonna like tell you like where you have to define the program or something like that. They're not gonna tell you. You're supposed to know that. Okay. So to print, you can call it example shows the need to... Okay. So, and then we do call, but that means it's inside of the program, right? Because usually you do this kind of stuff when you are like, oh, wait a second. This is a format string, and then... So that means this star that we put in print in here is sort of like a format string. That's very interesting. That is actually very interesting. So, and I wonder, like, I don't even know what's the problem in here. Is it because I legit made a syntax error? Cannot follow implicit none. Is that because I have to put it in here? Maybe that's what I have to put. I literally have to guess. Interface 2. Like, what kind of error messages are these? That's like, what? Implicit no statement, I cannot follow interface statement. Why? Okay, so what if I remove implicit statement? Why? How does that make any fucking sense? Like, what if I want to print a what if I literally want to define a variable? Or this is so bad. Like, I want to define a variable and I want to say implicit none. Right, and it's just like, dude, you can't do that because fuck you. This is... it is so fucking weird. It is so freaking weird. Okay, anyway. Oh. Wait. Oh my god. Ew. What a... Ew. Oh my god, this is so disgusting. This is the most disgusting language ever. Like, why is it like that? Why? What the fuck is wrong with these people? I don't understand. Like, why do you have to make it intentionally convoluted like this? So here's an interesting thing. C. C is a super simple language because people were trying to come up with the simplest solution because the computers were slow. They didn't write like a lot of complicated code in assembly just to have some high-level programming language. Like, the initial implementation of this was probably written in assembly. To be fair, this is probably all of this is probably modern stuff. Yeah. So original Fortran was actually way simpler than this, but man. Anyway, whatever. So let's let people gatekeep. If people want to gatekeep, let's let them gatekeep. So Okay, it complains about not being able to find this reference, which is already kind of good, right? So we have this thing in here, right? We have this thing in here. So let's go ahead, literally, and compile it with O. I'm gonna just assume that it is possible to do it like that. I'm gonna literally assume that it is possible to do it like that. And it is, in fact, possible to do it like that. And yeah, there we go. That's pretty cool. So we are capable of running C code or calling C code from Fortran, and that is enough for us to start epic game development in Fortran. Holy shit. So the next game development language is Fortran, not Jai. Fortran. I'm joking, by the way. John, please don't kick me out of the beta. I'm joking. I'm just joking. All right, so what do we want to have in here? What if I want to have several functions in here, right? So what if we create something like print B from B code? Can I have several subroutines? I literally need to check if I can have several subroutines here like that, because I don't know. This syntax is so wild, you can expect anything from it. Like, maybe you can't have two subroutines in a single interface. Like, the rules are arbitrary. I don't fucking know. Maybe you can only have like 1.5. Like, who knows? We need to double check that you can have several of them in here. Right. So, and in here, let's actually do B. B. And let's try to compile that and hope for the best. Of course, something went wrong. Oh, well, I mean, it's not that bad. But okay, you can have two of them. Like, we're not sure if we can have 3 of them. Maybe it's only limited to 2. Who knows? Maybe for 3 you need to have like a completely different syntax. We don't fucking know that. You can expect anything from this motherfucker. All right. Okay, so it seems to be working. That's nice. All right. That's pretty cool. How can we link with Raylib? I suppose we can link with Raylib pretty much directly. So what if we define a subroutine? So if you take a look at opt Raylib, include raylib.h, the function that we need is init window. Init window. So it's a function, it's a subroutine specifically that accepts 2 integers and 1 string. So let's go ahead and do that. So subroutine init window. So this is basically, it has to be cint. So we had an example for cint in here, didn't we? Yeah. Oh, this is such a weird thing. So I suppose we can say, can I do cint? Why is it like that? String is not a type, by the way. I think string is not a type. Is it? I think it is not. Yeah. So it's a name. So it's actually, this example is so tricky because it makes you think that maybe string is a type. No. It's a name of the variable. It's a name of the variable. Okay. So that means here we need to have width, height and title. So that's the variable we're going to have, and we're going to bind all of that to C, and the name we're looking for is init window. There we go. So here's the cool part. Unlike OCaml, we don't really need to have the C part. We don't need to like write wrappers. So we can directly just call C without any wrappers, because Fortran is basically on the same level as C, I think. Right, so I think they are. Okay, so the thing we need ISO C binding, and we only need C char, right? We need C char and probably C int, not init int. Then we're gonna define all of these parameters in here, right? So the width and height are integers, right? So C int. Why did I press that type init? So this one's going to be width and height, and I'm pretty sure I can do it like that. And then the string is defined like this, right? So we say that it's a character of this specific certain kind. So you can specify the kind of the character to improve interoperability. interoperability with C. Right, and then we say that it's sort of like an array. Right, if we take a look at arrays and strings, what is the syntax with the star? So they don't even explain you the syntax with the star. Okay. So all of that stuff is not even full. All of that stuff is not even complete. But I mean, we can just like stitch together different like existing examples and stuff like that. Init window. Okay, so now we can try to call this entire thing. We're gonna do init window. It's gonna be 800 by 600. We have to call it though, right? So we have to call this entire thing, and the title is gonna be Fortran Goatee. Not Goatee, but Goatee. And since it's a C string, as you can see, we have to concatenate it with null terminator, right? We have to concatenate it with the null terminator. And do we even import? Yeah, we do import the null terminator from here. All right, so I think we're ready to just test all of that out. It's not going to work, by the way, I'm pretty sure, because, so cannot change attribute of use. So where is an example? Yeah, you can have this kind of stuff. So you can have several parameters in here, that's for sure. Must be a dummy arg. Oh, I'm sorry, I copy pasted. I'm an idiot. So it has to be title. That's right. I just copy pasted this thing. Yeah, this name of this variable tricks me into thinking. Tricks me into thinking that this is a type, right? It tricks me into thinking that this is a type, and I just like I skip over it. I keep skipping over it. It's so funny actually. Okay, so what else do we have in here? Can I change of use association? Why it is like that? Why it is like that? So maybe I have to have this as separate things? No. Attribution of use associated int. Does it mean that I have to do that for each of them? Is that what you want? No, I don't really have to. Right, because it works in here. Right, it works in here, literally. So I just like sort of import one cint. Okay, so you probably can't use these things directly. You have to say it's an integer of a kind cint, similar to how you do that with the character, right? So you see, in character you have to, yeah. So you kind of have to specify the mapping between the C types and the Fortran types. Right, I can see that now. All right. And now it works, and now it says undefined reference init window. So we need to link that with the array lib. So let me see, Fortran, does it have any flags that we could have used? Link, does it have like -L? Okay, so the way we usually link is L array lib. Oh, it's part of GCC, so that means that all of the like usual flags should probably work, right? So they should probably work, but we don't know for sure. Okay, so let's try to build this entire thing. Cannot find. What does it mean? Does it mean you can't find the library or the flag? What if I do? Oh, it complains. LD complains. All right, that's fine. So if I do something like LDL, it will be able to find that. But if I do array lib, it's not able to find that. So, and we probably can do something like L home opt array lib. Honestly, in opt we have array lib environment, which actually uses package config. We can probably use a package config in here. So let me restart Emacs super quick, and we're gonna set up the environment for array lib, the development environment for array lib. There we go. So that means we should be able to do package config c flags array lib. There we go. So that it does the includes and also the libs for this entire thing. So, and this is the thing that we'll probably need in here. Okay. So now, if I go to build sh, I should be able to completely replace this thing with something like package config libs raylib and chat. Are you ready for an epic first try moment? Build.sh. Boom! It didn't fucking work, but that doesn't matter because we are on the right track. So what we just need to link with glfw. glfw. There we go. And it also needs LDL. Okay, so we're gonna link with that. And we also need to link with pthreads. Can we find pthreads? Okay, pthread. It crashed. Oh, but look at that. It initialized raylib 4.6 dev. And then it crashed with an assertion. We can even go there because I built raylib completely from scratch on my machine. It actually, all the assertions tells us like correct place where they happen, so we can even inspect the source code of raylib. Yes, as you can see, it is a raylib because I built it in here. Isn't that cool? So not only it, like when it's crashed, it will also tell us the things inside of here. So what it tells us is that width, for some freaking reason, is 0, and I have no idea why. It shouldn't be the case. So maybe it says it's negative, but one of the things we can do, we can actually print debug this entire stuff. So let's take a look. Yeah, it shouldn't be the case, right? I'm passing, you know, 800 and stuff like that, so maybe I have to do something like this, title, to sort of like explicitly tell it what it has to be. At least it didn't crash, which is already good, and it still says that width has to be greater than 0. So, right. So, and width is something that we pass in there. So, it's either negative, or it's either something else. It's hard to tell, but for some reason it doesn't really pass this kind of thing in here. Do we have debug information? Because I kind of want to see what is it equal to. So let me see. So maybe it is float. That's a good point, actually. Let's do the following thing. Integer, width, height. And then we're gonna do width equal 800, height, which is something that we want to do anyway, right? Because I want to have these variables defined somehow, because I'm going to define other things in terms of these variables. That's a good point, actually. Thank you so much. There you go. Thank you so much, Morton SQRT. Thank you. So by default, I suppose the literals are floats, and we have to be ready for this kind of stuff. They default to float, apparently. Welcome to Fortran, right? Where anything can screw you over. Alright, so I think we're ready to maybe define the next function. Right, let's go to raylib, opt raylib. And it's so much more pleasant than working with a camel, where you, for each function, you have to like define also a wrapper. So here you only need to define the, you know, the declaration. So set target, I think it's called something like set target FPS. Right, and this should be pretty straightforward. Subroutine set target FPS. And FPS is going to be just an integer. So C name set target FPS and subroutine. Oh, look at it. Can I do? Can I even do something like? No, I have to put end in here, and I press tab. Emacs. I press tab twice and it just closes that stuff automatically. That's kind of cool. I suppose the only thing we need in here is an integer, and the parameter that we have in here is essentially integer of the kind cint, so this is FPS. So that means we should be able to then call set target FPS, and we're gonna set FPS. Can I define these kind of things? 60. That doesn't even look that bad, honestly. Like in terms of like readability, except this part. This is horrendous, but this stuff is actually kind of nice. Right, so these are all the integers. Like I set them up and I call to this C library. Right, and let's see. So it complains about something. Implicit. Did the rest of the thing just default to floats? Because it complained. What if I say integer? Don't tell me that they're gonna default to floats. It works fine. If I put them on the same sort of line, it doesn't work. It's literally an intercall. Do you guys know what is an intercall? Intercall. It is literally intercall. Like, holy shit. Why people were making languages like that? So it's a compiler language with no pronounceable acronym, right? Intercall. It is an esoteric language that was created as a parody by Don Woods. So the point of this language, I think, is that you have to say it can screw you over randomly, as far as I know. It can screw you over randomly. One of the things it has a keyword please, right? So it has a keyword please. And essentially, you have to be polite for this language to compile. So if you're not polite enough, your program is not going to compile. But if you're over polite, it's also not going to compile. So you need to have the right amount of pleases in your program for your program to compile. And you don't really know like how it's going to compile because it's a random number generator. So this is intercall, and this is one of the things that can screw you over. It has like several of the things that can screw you over like that. This is literally like intercall style esoteric language. Like, I swear to God, like, what the fuck? Like, right, I really recommend to actually read about it. So, yeah. In the description, so where's my description in here? And this is supposed to be like a serious production language. Please, yeah, so you have to put please integer. Why? So, okay. So, and what's funny is that it's not the height that became float, it's actually width that became float, which makes it even more confusing. I don't know. By the way, keep in mind that I'm basically using Fortran for the first time in my life. Okay, so what you're seeing in here is actually my genuine first reaction, maybe. But if I programmed ever in Fortran, I probably forgot everything. So you can basically consider this my genuine first reaction. So if you want to tell me that I'm ignorant and stupid and I didn't read documentation, and you would be right, because I didn't read documentation. So this is me reading documentation for the first try. And this is my first reaction. This is the reaction of like person seeing this shit for the first time. And this is how it looks like. Yeah, I did not read the documentation because that's the point. So that's how I would react if I didn't have any documentation and I was dealing with this thing for the first try. So that's the truth. If you don't like that, I'm sorry. Right? It is what it is, and it isn't what it isn't. All right. So, but what's important is that I still get the shit done. So people criticize me for complaining a lot. And it's a valid criticism. I do agree with that, to some extent. But you need to ask the question, Do I get the shit done? Does my program compile and call to raylib and initializes the raylib correctly? It fucking does. Maybe I'm complaining a lot, but I get the shit done. And that's what's important. You only have the pass to complain if you get the shit done. If you complain and don't get the shit done, get the fuck out of here. You need to get the shit done. Only then you're allowed to complain. But on a serious note, I don't know why I am like that. I think I already discussed that. When I go into the flow, when I become like hyper-focused, I become like super critical of everything. And because of that, I may seem like I'm irritated. So it's more of like maybe physiological reaction or something like that. So, you know what I mean? Kind of like outside of this hyper-focused state, I'm actually not that complaining, to be fair. Right. It's actually quite the opposite. All right. Outside of the hyper-focused programming state, I don't really complain much. Trust me. Trust me. So I don't know why. Maybe it's something like physiological with the brain, so with the wiring of the brain. Anyway, whatever. So I'm just coping. So the next thing we need to do, we initialize the window, we set the target FPS, and that's basically it. The next thing we need to do, we need to organize the loop, and we don't know how to do the loops in this language, goddammit. All right. So let me see. There was a section with the loop, operators and flow control. So this is probably something that we want to have in here. Loop construction. So we have do construction, right, which is a for loop and stuff like that. There's a do while. Sorry, only Russian speakers will understand the joke. We probably want to use that. But before we can use do while, we need to create a binding for should window close, right? Because you're supposed to do while the window should not close, just keep executing the body of the loop, right? Just keep executing the body of the loop. So window should close, and that is not a sub procedure or a subroutine or whatever the fuck they call it in Fortran. I think it's a function. Window should close. It doesn't really accept anything, and I suppose it should return something. So you actually bind the functions slightly differently. All right. Yeah, there we go. So you put the return type in here, which is fine, I suppose. Do we have? I think it has to be logical. Yeah, it has to be logical. But in raylib, we return boolean. Can we have like a cbool? We can have cbool. At least Emacs says so, which is nice. Okay, cname window should close. Alright, and can I end function? Do we have to say end function? So here we don't really have an end function, which is rather weird. Starting shaking. Like, it makes sense to have an end function here, but it... Maybe you don't have to, because Emacs doesn't... Well, you probably have to have it. Emacs auto-completed it. So, yeah. Use ISO C bindings, only cbool. Alright. Is that it? I think that's it. So let's try to... Yeah, at least it compiled. Do while window should close, right? And I probably have to do call. Yeah, call window should close, and then we have to do end do. I really like this feature of Emacs. It's a very cool feature. So you open the block, and if you want to close the block, you just press, you just type end, and you do tab twice, and it just automatically does whatever you want. Right. So this is actually kind of cool. Okay. So, and what we have to do in here, like, I don't really know. So let's just try to compile and see how it is going to react, but I don't want to run it because I don't know what's going to happen. Oh, wait a second. Okay. Unclassifiable statement. Ah. So call is a statement, so you can't use call in an expression. But how do you... Wait a fucking second. So subroutines, calling subroutines is strictly a statement, but calling functions is an expression. I see how it is. That's a very interesting way of thinking about it from the language design point of view. Okay, so that means you don't really need call in here because it's an expression, and it's an expression because it's a function. Subroutines are statements and functions are expressions. No, it's not true. Unclassifiable statement. Is that because I have to have something in here? Probably. So is it because I have to wrap this stuff in parentheses? Alright. How can I do not? Is there something like not? Oh wait, I think I remember. I think it's like something like dots, a weird like... Yeah, I do remember. Yeah, I remember seeing it at some point. So I have some phantom memories about Fortran. Yeah. Because this is such a weird thing, it's sort of stuck in my head from the times when I saw something about the Fortran. Yeah, it's just like not... and it works. Okay, that's cool. But it's kind of dangerous to run it like that because when you're doing a loop, you also have to do begin draw and end draw. So let's actually introduce begin draw and end draw. Luckily, they don't really accept anything. Right, so they're basically subroutines without any parameters, which is nice. And I wonder... Alright, so this is begin drawing. We don't accept any parameters. Begin drawing. So that means we don't need any of this stuff. So in here we have to do call begin drawing, and then we need to have end drawing. End, and this one has to be end. All right. What if we try to run this entire thing? Huh. I think it created a window, but it was lagging. Which raises the question why. It created a window that... I swear to God, it has something to do with integers in here. Okay, so let's comment out all of this stuff in here. And I want to print the values of width, height, and so on and so forth. So this is width, height, and FPS. Show me what these things are. I just want to see them. Because this is a dangerous language. Okay, so these are the integers, right? And if I do something like plus, 0.69, it is not going to change the width. Well, technically, okay, so one of the things we probably have to do is width equal width plus 0.69. Right, and essentially, is there any way to cast things to specific values? So init window, all of these things is an integer, this is an integer, so everything is an integer. I don't know why it is like that. Is this because... Oh, this is a good point somebody said in the chat. Yeah, Mohammed12211. This is a good point. What if we have to do the same thing here? Thank you so much. Is the stream okay, by the way? I think the stream is okay. This is a good point. What if it's just like, yeah, we have to explicitly say what kind of integers we have in here? That's a very good point. It might be actually the case. So, but it's probably not going to compile. Right, so because it's, yeah, you cannot have that. Has no implicit type. So we have to sort of do this thing. Yeah. Assertion width has to be greater than 0, so it fails yet again. It fails yet again, so, and I have no idea why. Classic. So let me think. I'm thinking what's gonna be the next strategy, like how we're gonna approach this entire thing. We can try to rebuild the raylib at that specific place to print width and height, because I want to see what kind of width and height passed there. I kind of want to see it. Another approach could be to do GDB. Another approach would be, is it because one of the argument is named? Probably. We can try to get rid of the named argument as well. That's a good hypothesis. So let's give it a try. Yeah. Okay. So for some reason it creates a huge window that takes up the whole screen. Right. So I have no idea why. But it still creates a window that is responsive, by the way, because I managed to close it. Right, so if I do that, it's just like, yeah, it creates a huge window. Does it start lagging as well? I wonder. So that is rather interesting. That is rather interesting. So let me take a look at software raylib build cmake cache. Do we have a debug build? So maybe if we take a look at the raylib file, does it have archive? So let me just try that, gdb foo, and I'm gonna try to break at init window. Can we do that? We can. All right. So, all right, that's perfect. Why? I don't fucking know, right? Okay, so what about the title though? Title passed correctly, look at that. The title is passed correctly, it's Fortran GOTY, Game of the Year. But width and height... Okay. So what else do we have in here? So width and height, integer. Right, so let me take a look at these kind of things. So yeah, so that makes sense. That's how we do that. Oh, wait. To pass variable by... Oh, I forgot. C passes by value, but Fortran passes by reference. Oh. And I read that. I can only blame myself for not, like, for forgetting about this thing. Okay. That's fine. Epic. Absolutely epic. We need to also clear the background with a certain color, right? Let's clear the background. Clear, where's the clear? Yeah, here we go. So it accepts the structure. It accepts the structure, but it's a 30-bit, 32-bit structure, right? So maybe we can pass it as an integer, but we don't really know the size of the integer. But it's actually cint. Huh. Is there something like cuint? So this is cint. What about cuint? Unsigned? Nah. C? So can you autocomplete? Yeah. Ooh. Alright, so there's all of these things. So fast, cuint. But do you have... It doesn't have unsigned. Only int. But that's what we can pass in there, right? So we can pass 32. By the way, interoperability with C. I remember they had derived types and structs. Yeah, there we go. Type bind C my type. We can try to do something like this. So, because it's supposed to be a structure, but that raises the question, do I have to put it in here or somewhere else? Or like, where do I have to put that? I'm not particularly sure. And also, do I have to put it somewhere else? Alright, so let's start with bind C, and this one is going to be caller. And if we take a look at the definition of caller, right? Caller. It's just like unsigned character. It's just unsigned character. Maybe here we can say only C. But where is an unsigned character? How do I define unsigned characters? Is there any list of types? Intrinsic types. ISO bindings. Yeah, they are. Where unsigned? Dude. They're only signed in here. No unsigned values in Fortran? Okay. You know what? Fuck it. I'm gonna just pass cint32. That's what we're gonna pass in there. Just like oh yeah, Java, the classical example of that situation. So let's just do clear background. Clear background. We're accepting the caller, and the caller is going to be. So we're gonna put this stuff in here. We're returning int 32t and c. So it has to be an integer. C int 32. I think I'm getting the gist of this thing. I think I'm getting the gist of it. Every time I say that, something is gonna scroll over me very quickly. So, and I wonder if I can do the following thing: call clear background, where I can say something like ff 0000ff. Can I do something like that? Can I? That's a good question. I can't. Okay, so Fortran hex literals. Is there something like hex literals in Fortran? Hexadecimal constants. All right. It's too big. Because it's signed, and that's why I was asking for unsigned. Oof! Holy fucking shit! That's like, to make this trick work, it has to be unsigned, but it doesn't support them, and I can't even do this kind of thing because it's bigger than signed one. Well, you can disable the range checks, and this is one of the things we can do, probably. One of the things we can do, we can actually use the negative value. Can we reinterpret it as a negative value? Is it possible to do that somehow? Right? Can I don't think so. Let's try to do no range checks. Maybe that will work. Oh boy. Okay. And it didn't work. That's cool. Right. Do we even call it? I don't think so. Is there an easy way? Is there an easy way to convert that hex into a negative one? Or do we have to do some stupid shit like... Okay, so we can try to do the stupid shit. Let's go ahead and do that. Right, so this is gonna be stdio, stdio.h integer, and we can do uint32 caller. Printf d pointed to the caller. We pawn it into the pointer to the integer, and we dereference it. So we literally reinterpret the bits as assigned value. Right, so GCC, actually clang, doesn't matter, main.c, let's just run this entire thing, and it is this value. So now, if we pass this value to here and try to do the build and run it, it still didn't freaking work. You know why? Probably because it interpreted it as float. Maybe, I don't freaking know. So let's actually try to do something like this, integer, just in case. I'm not sure if it's needed or not, but just in case I'm gonna put this thing in here because I don't know how Fortran works. Right, so in here we're gonna have a caller, right, and in here we're gonna say caller is equal to this stuff. So this is the caller, just in case, because you never know, you don't know what to expect from this thing. So yeah, you have to have that stuff in there. All right, and it didn't work still. Okay, so maybe there is something with a clear background. We pass it by a value. I'll begin drawing. Clear background. Yeah. There we go. This is the dumbest hack I've ever written in my entire life. Holy shit. But it works. Again, I may be complaining. I may be even doing it wrong, but I get the shit done. I get the shit done. It is working. It is twerking. Yo, what the fuck? So, okay. I get the gist of this language. That's a good language. 69 out of 69. So yeah. Now I can even kind of read it. I would like to do a little bit more in this language, right? So maybe we could try to, yeah, make a full game, like a small full game out of that, like tic-tac-toe or something. Right, so maybe I'm gonna do more streams on this kind of stuff, right? So I think it's promising. I think it is promising. So yeah, that's pretty cool. So let's take a look at other subs that people probably gifted and you know, bought. Thank you so much, Hector84. I think I already acknowledged you. One Amona, thank you so much for Twitch Prime, and then Incredulous Buffoon, thank you so much for 10 gifted subs. Thank you, thank you, thank you. All right, that was pretty epic. So, and well, I mean, I'm complaining a lot, but that was surprisingly straightforward. That was surprisingly straightforward, right? So we did have some roadblocks, but there was nothing impossible to figure out, you know what I mean? Nothing really impossible to figure out. Like, we figure out majority of the things. So I guess it's fine. I guess it's a passable language. It is in fact passable language. All right, so I'm already streaming for more than 2 hours. I think that's it for me for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreational programming session with Azuzin. I love you. Mwah.